where I'm from. Mate. Anyone here been to New Zealand? Anyone travelled that far? On the train? Great, fantastic. Okay, well, I'm from New Zealand, so I will try and slow the pace down, if you like. That's why you ever see Lord of the Rings? When they play Lord of the Rings, it lasts for 1 hour. We play 3 times the speed, but you export it and slow it down to never speak too fast. Anyway, but Tekla, New York, what we've got is a great project I want to talk about. I want to talk about the process that's making that project happen. 3 parts of my next 15 minutes. About the problem, where we need to get this right, first time, on time, which is very much the Tekla story. The search for a solution, and then of course the solution itself, which is all about LOD 400, 500, and 24/7. And I'll explain those numbers before the end. But let's start off with a nice little lead-in.
They say you can tell you've become a real New Yorker the minute you stop looking up. Looking up's for the tourists, for the recent transplants, the people who don't have work to get to, a train to catch. Looking up's for the dreamers, for children who haven't yet outgrown their surroundings, for anyone wide-eyed enough to believe New York still lives up to its namesake as someplace new. But we've heard a different story. We hear there are still neighborhoods to explore, still places to get lost in, still secrets worth finding, that there are still victories to toast, stories left to tell and be told, heights worth climbing, that there are still connections to make, perspectives to consider, and celebrations to come. We've heard that there are plenty of reasons to keep looking up.
That's the promo for Hudson out to New York. Who's been to New York from here? I haven't had the chance. And did you look up?
All the time, all the time.
Well, keep looking up, because next time there's a whole part of New York which is being regenerated. It's called Hudson Yards. It sits on top of a railway track, and Tekla, of course, is well in the centre of getting those models and those buildings together. So it's just near the World Trade Center, just north of that. Lots of really big projects going into one of the towers that's been done in Tekla. Lots of really big numbers, of course. And as I say, this is a massive scheme. It's $20 billion US dollar construction scheme. It's for the whole area. Mainly, a lot of it's down to the cost of the land, obviously. But in there, you've got some of 30 Hudson Yards. It's this building. It's not this building. Completion by 2019. It's around about the height of the Empire State Building. Lots of floor. And the architects are KBF, and the engineers are, of course, Thomas City. And don't forget, in the US, it's very much like, I guess, in Denmark, the architect is very much drives the project. The engineers are employed under the architects, and so it's very important that that team works together very well. So how's this going to happen? Well, KBF, of course, want as much detail as possible. Of course they do. Because when you're doing cladding, setting out, when you're doing all of your setting out of your building from face to face, you want to know how you can maximize your office area, and you can minimize the spend on the buildings. LODs are really important, and you want to avoid redrawing structural. And they're essentially, in many ways, in all my years as an architect, that's what I wanted. I wanted as much information from the engineer that I could, that was accurate, so that I could reuse that. And of course, that's what we had with DWGs for years. And that's the background, I guess, of what an architect wants. Is they want to have as much information as they possibly can, so they can reuse that and set out to that. And it's very much a DWG story. So what is a LOD? That's the term I just used. The LOD 350, for example, level of development. Very much you guys have this already. For years you guys have been talking about levels, 1 through to 4 to 5 to 6. And the LOD is kind of I guess a phrase that's being built out of the BIM story. We're trying to explain what exactly do you need to deliver as an architect on this project, or an engineer or MEP guy on this project. What level of detail are you working at? Most of the models that I see across OPS these days that I work in software are about LOD 300 for architectural. Very rarely do I see architects going down to actual panels within a facade, actual frames, actual flashings, that kind of thing. Very rarely do I see that because it's very hard to get that detail into a model. This model here, which was done by KPF and Revit, is broken down into 3 separate projects, obviously. You can't get the whole thing in one. Engineering-wise, that means that LOD 300 is about here. Challenge, of course, is that Tekla instinctively, out of the box, goes to 350, 400 very easily. It's very hard for when you're using Tekla to model down here because the way it's set up is that it's always been designed for LOD 400 to 500. And it does it automatically, as you can see here. So it's just me trying to play around, trying to get Peter's work here. Thanks for Peter for this, by the way, to recreate this. But it's very hard to actually just create half of a LOD story. So that's the challenge. Is that Tekla is very much a product that designs to the end game from day one. It's very good at doing that. So the challenge is the architect's working up here, engineers will be working down here. So how do they work together? And then of course you've got the contractor. What does he want? Well, the contractor wants what he always wants, and what he never really had with DWGs in years gone past, is he wants it right first time and on time. And of course that's the real benefit of the Tekla model, because we're going to start way down here with the pins and work backwards upstream. And so it's all about delivering exactly what that guy there needs on the day, right place, right time, first time. No mistakes. That's the story that we're trying to chase there. Because that's when you're saving time and saving money. You don't want to install these guys in. That guy brings it in, places it, doesn't fit. Doesn't work. Search for a solution. So this is what Colin Thomas said. This is the engineer of this project. They're trying to get rid of this fact in here. All these potentials for delays. There's this kind of, these are these different kind of phases. Develop design, construction design, bidding. What they're trying to do is move all that backwards. How can we bring all the connection design in-house? So they bring guys in-house, like steel detailers as part of the project team. They bring the middle order way back into develop design. They bring all the connections way back here. And so they remove all of this risk in here of delay because they have this team working in one single model, doing not only the engineering but the detailing, so that way all of these phases reduce their risk, corrections, minimum, etc. This is why Colin Thomas said he used Tekla on this project. It's because you can have everyone in the same model very early on, and you can reduce delays later and risk. The other problem they had, of course, is that Colin Thomas said he is global. They have offices not only on the project site but around the world. How can you utilise that whole team, which are around the world? They're in India, they're in Europe, they're in US. How do you use the whole team on this massive project effectively? Okay, the solution, of course, Tekla structures, first solution, right first time. So Colin Thomas said this is a classic Tekla story. Check out the website, loads of webinars on this. But they use Tekla all the way through, as I say, superstructure, for the long span roofing, specialty productions, connection design, correction engineering on site. One model all the way through. Engineers as well as detailers on the same model working through these connections. Classic Tekla story. That's not new to you. The model is massive. It's actually the biggest we've ever seen. Had the guys sitting there in the HQ sweating that this one's really going to hold together, but it certainly is. 750,000 geometric parts in that model, not including points and sheeting stuff. Real bolts and beams and stiffness, all that kind of stuff is all in there. And it's all at LOD 400 plus. That's an engineering model. Lots of detail, loads of detail. Actually, and the question is, and then the architect says, could you please send us your model? You know, you're going, are you serious? What am I going to send you? And as this guy says, Jeff says, don't waste our time and fee giving them something more advanced than they need. And this is the things that Colin Thomas said he finds working with architects. You've got to be careful what you give them, because often they don't really know what's available. They can't have the whole model. So for basic stuff, we're talking about for collaboration, when you're going out to the architectural team, contractor team just want to coordinate, IFCs are absolutely fine for that. Navis is great, they're really good at IFC import, Revit's okay, you bring it in, and also, but if you are doing, like I've seen at a few of the presentations here, if you are doing more deep stuff, like referencing the structure, or if you're doing scheduling from the structural model, etc. within Revit, you can bring it in. We have links that take it out and bring it into Revit, allow you to link it through to your architectural model. And this is the key thing, those links then will maintain the Revit ID between updates. Okay? Bring it into Revit, IDs are maintained, update it, IDs are maintained, same part. Okay? Those two are there, absolutely. This is what Full Autonomy City does to KPF. Mostly they give them ISC because they're just coordinating, they're just saying, does it fit? If they are doing strange, well, if they are doing things like core walls or like columns, and they want to maintain those from the Tekla structures model, they use this one here. And the great thing is that ISC is excellent change management. So when KPF send it back into Full Autonomy City, we can pick up all the changes in the model. This is using the ISC open bin workflow. If a beam changes, profile, place, whatever, we can pick it up. But of course, when you go the other way back out to Revit, you've got to know the story. This is coming through from Revit users. If you use Copy Monitor, you go from Revit to Revit, you can't pick up changes. You can't pick up changes in beams, that kind of thing. Okay, so the only way you can communicate Revit structures to Revit architecture is through using drawings. You've got to use the clouds because Copy Monitor won't pick up those things. Unlike, of course, ISCs, you can pick up everything, but there's just limitations in software. So Revit to Revit doesn't pick up changes. Use your drawings. So 30 drawings coming off this model, no problem. Just cloud them. KPF love it. Everyone's happy. Next thing, on time. Okay, you've got like a global team. So how are you going to distribute that work across the planet? 1, 2, 3. Some way you're going to try and work together. You put all the model in one place and do these really fast VPN links in, and so this doesn't work. Everyone knows that this is a real challenge. What we've done with these guys is because they work around the world, these are all the offices, places they can work. We built something new called Tekla model sharing. Tekla model sharing is all about sharing the changes, not the model. This is extremely light. So all the models are actually native. Here, the model exists in multiple places, but only the changes are shared. So in this one here, this is a lot of data has been shifted across the server. 112 users in the model, 38 in one model on a daily basis, working on that 24 hours a day. I'm not quite sure what happens on the Saturday or Sunday, but anyway, this is what they say. So what they get is extremely light transfer of information on this massive model 24 hours a day. So extremely efficient way of working. So the engineers are not behind time. I can guarantee you that they're always waiting for the rest of the design team to send them information. Very successful. That's how they're doing it. So what does it look like? Well, on your screen in the Tekla structures, you just log in and you start sharing. There is no IT backend, there's no installation to server, there's nothing. The whole thing is handled by Tekla. It's licensed, it's extremely cheap, and all you do is you start sharing, and away goes the model. It's that simple. So your IT department will love you. So that's me. I'm in on time. People asking, how do they do it? Well, they're going LOD 300 out to the architectural, 400 to 500 out to the space. You need to know when this stuff is coming in and it's the right size, the right first time. He gets really upset when he's putting in a beam and it's the wrong size. And trust him. So Tekla structures for these guys, and Tekla model sharing for the design team for 24/7 modeling. And don't forget, next time in New York, look up, there'll be some changes in the skyline. See you there. Thank you very much.